Good afternoon. This is one of the Mr. Precellas. Today in algebra we're going to be discussing factoring. And factoring is one of those things that's not really, it's taught in Math 371, the developmental math course, and we sort of assume you've done it before, but it's important enough we need to have an assignment over it so you really remember it. Factoring is sort of the opposite of FOILing out. In algebra classes, I say this over and over, in algebra classes you always do the stuff one way, then you do it another way, in reverse. We first FOIL, then we factor. You do it one way, then you do it in reverse. As we go through this semester, you'll see that that's especially true in this course. Let's start FOILing this out. 5x times 3x, is that a 15x squared? I thought this pen was pink. It looks pink, but it's not. So there. It's black. 15x squared. So that's first. Now I'm going to do the outer and inner in red. Is that going to be a minus 20x? That's first. Outer. What about the inner? Is it a minus 6x? And what's the last term going to be? Negative 2 times a negative 4 is a positive 8. Now, we're not finished here. If you recall when we were doing these with i's, you'd have to replace I squared with negative 1 before you combine anything. Here, the only thing we're combining are the outer and inner. The negative 20x and the negative 6x. When we combine those, what would we have? Let's see. 15x squared, negative 20 plus a negative 6. Is that a negative 26x? And then plus 8. Okay. What we're going to be doing today is the reverse. Starting with this 15x squared minus 26x plus 8, go back to the 5x minus 4 times 3x. No, 5x minus 2 and 3x minus 4. So we're going to be coming up with those two sets of parentheses. Let's do one more of these. 4x minus 5 times 2x plus 7. If we start FOILing that out, let's see, what's the first term going to be? 8x squared. Now let's do the outer and the inner. Just to be consistent, I'll do those in red. Let's see, we would have is that a plus 28x? And what? A minus 10x? So first, outer, inner, and now the last, what's the last term going to be? A negative 35? Is that what I heard? That's right. Now, just like the previous one, we combine the outer and the inner. We have 8x squared, 28x minus 10x. Is that a positive 18x? And minus 35. So let's start imagining that we're going to go backwards. We have this stuff right here, and we want to figure out these parentheses. Well, the first terms here, these first terms, you get by FOILing or multiplying the first two terms, the 5x, the 3x, the 4x, the 2x. this last number, the number I have in blue, that comes from multiplying out the last numbers. To get the middle term, that's the outer and the inner. Okay? You combine the outer and inner terms, and that gives you this middle term. Think about what sort of numbers multiply together to give a positive number. What sort of numbers multiply together to give positive? Two positives and what else? Two negatives. Okay? If you're going to multiply two numbers and get a negative answer, then what do you have to have? One positive, one negative. If you look at this last symbol here and here, like this plus 8, if you're going backwards, trying to figure out what goes here, if this symbol is positive, then that means either you have a positive times a positive or a negative times a negative. The way you decide which one you have is by looking at this symbol right here in front of the 26x. I'm going to write a little table to sort of help us figure out how to arrange the plus signs and the minus signs. And I'm going to be referring to the first sign and the second sign. If we have something like these things right here, I'm going to call this sign here and here, the minus in front of the 26 and the plus in front of the 18. I'm going to refer to those as the first sign, and these symbols here as the second sign. And I'm going to make a bizarre looking little table that won't make much sense until you know how to do this stuff, okay? So, second sign. Ooh, I don't like that blue pen. Today is the day where I'm getting nothing but pens I don't like. Last week I had such nice pens. If the second sign is a plus, then the factored form, the only way you would get a positive for that last number is if you either had two negatives or two pluses. To decide which one, so second sign, factored form, let me go ahead and draw my horizontal lines for this table. There. Okay, so if the second sign is plus, the factored form has two of the first sign. Two of the first sign. The only way you could have a positive number there at the end is if you had either negative times negative or positive times positive. Whereas if you have a negative last number, the only way you're going to get two numbers to multiply and give you a negative is if you have one plus and one minus. Third column that says fill in. If you have a plus as the second sign, you can fill in the signs immediately. Why? Because you know they're either two pluses or two minuses. Just look at the first sign. On the other hand, if you have one plus and one minus, I'll wait to fill these in. Why am I waiting? Because I wouldn't know whether the plus goes in the first set of parentheses or in the second. Now, looking at this middle term here, how do we get this middle term from the two, the outer and inner terms? How to get middle term from outer and inner. Well, looking up here where the second sign was plus, you have a negative 20x and a negative 6x. You add those numbers together to get that negative 26. Whereas when the second sign is minus, like the 28 and the 10x, you're subtracting those. Okay. At some point in a previous algebra class, you did some factoring, okay? So it normally follows up after you do foiling. The next chapter in the books are usually factoring. You FOIL it out, then you go in reverse and factor. Well, I'm going to start doing some examples. Oh, actually, before I do that, there's something I should mention. When you're doing this factoring stuff, you're coming up with the two sets of parentheses. There should not be any common factors other than 1 in the parentheses. That'll actually help you figure out or discard some possibilities. Because we're just going to sort of be guessing and doing a trial and error process to find out what goes in the parentheses. Now, what do I mean there should not be any common factors other than 1 in the parentheses? Suppose you're trying to FOIL something and you have this. 4x minus 10. Could that ever be one of these sets of parentheses when you're factoring and getting answers? Well, no. Why? What number other than 1 divides into both 4 and 10? 2. You can't have that. There cannot be any common factors. What about 9x plus 10? Could you have that? Well, is there any number other than 1 that divides into 9 and 10? No, so you could have that. Oh, no, this one's going to be tricky. What about 5x minus 5? 5 divides into both of those. You can't have that. In general, you can never have two even numbers in the same set of parentheses. You sure can't have two of the same number. Okay? No common factors other than 1. And sometimes that's going to help us figure it out a little bit faster. Okay? So, let me do an example. I'm just going to sort of jump around through some of these problems. Problem number 2 is a good one to start with. Okay, it says factor the trinomial. Note that the coefficient of x squared is not equal to 1. Well, we'll see as we go through these that if that first number is a 1 in front of the x squared, those are the easier ones. But this is problem number 2. Oh, also, there's that option here that the polynomial is prime. Prime means it can't be factored. It's certainly possible that you might get something that doesn't factor. Okay? And I'll demonstrate that before the class is over. But right now, this is problem 2. Let me write it down. 6x squared minus 5x minus 21. Okay. I'm going to start off by drawing my two sets of parentheses. We're actually going to just sort of be foiling this stuff out in our head, kinda. Let's see. Let's start off by deciding what signs go in these parentheses. Are we going to put plus plus, minus minus, or one of each? That's what this table is. If the second sign is plus, you have two of the first sign. If the second sign is minus, you have one plus and one minus. Well, here, what's our second sign? Yes, this one right there. There's the second sign. The second sign is a minus, so there's going to be one plus and one minus. But I don't know where that plus and minus go. Does the plus go in the first set of parentheses or the second? So I'm just going to make a note that there's a plus and a minus, and we'll fill that out, or fill that in a moment. Now, this first spot here and here have to multiply together to give us 6x squared. Well, the x squared is easy. You just put x and x. But, oh, wow, 6. Well, what numbers multiply together to give 6? So, I'll write it out. What numbers multiply together to give 6? Well, a 1 and 6, and a 2 and 3. So the first two spots multiply together to give the 6. The last two spots multiply together to give 21. So let me think. What numbers multiply together to give 21? There's 1 times 21, and there's another pair of numbers. 7 and 3? Is that what I heard? If you do enough of these over your lifetime, if you spend 30-something years factoring, you're going to eventually decide that usually it's the numbers that are closest together on the number line that are going to work. Okay? I have a feeling the 2 and 3 and the 3 and 7 are the ones most likely to work. There's only one correct pairing that'll work. I'm going to try the 2 and 3 first. If at any time, however, we ever get a large middle term, if you have a large middle term, then that might be where you wind up using the 1 and the number. Okay? But there's no set rule on these. The way I'll go about it is like this. I'm going to take the 2 and 3 and see if I can make it work with the 3 and 7. 2 times in my career I've had hostile students, different students, once in trigonometry when we were doing these formal proofs, and once in algebra when we were factoring. And both times those students said, "You're just making this work out." And the students in the class laughed a little, and I thought, now how am I going to diffuse this? All of this real fast going through my mind. And I said, "You're right. You are exactly right. We are making this work out." So that's what you've got to do, is you've got to make this thing work out so that when you FOIL it out, you get 6x squared minus 5x minus 21. I remember telling the student, this was in 1992, way before a lot of you were born. I remember saying, "Oh wow, I'm going to remember that. I'm going to tell my students that." Little does he know, 30 years later, I'm still talking. Oh my God, not 30, just 20. Please tell me it's just 20. It's 30. 30 years later, I'm still talking about that student statement. You're just making it work out. That's right. So I'm going to put a 2 here and a 3 here. Yesterday, my brother was here, and he was trying to get me to do it in pencil some, so that in case I got to erase. And yeah, but I'm using ink just because it shows up better. So I'm going to try this with a 2 and 3. And I'm going to try to pair it with the 3 and 7. If this is going to work out, I cannot put the 3 right here. We can't have the same number in both sets of parentheses because they'd be a common factor. So let me try it like this. If I put the 3 here and the 7 there, now can I make it work out? What do I mean by that? I've got to get those outer and inner terms to combine together to give that middle term. I'm going to make these strange looking little rectangle marks for outer and inner. Imagine foiling. 2x times 3x, that's given the 6x squared. This big rectangle mark right here, that's the outer. 2x and 7x, no, 2x and 7, that would be 14x. That's outer. What would inner be? I'm going to write it right here. Is that 9x? You're following what I'm doing? I'm foiling out the outer and the inner. That needs to add together to give, or combine together, I mean, to give a negative 5x. Well, can I subtract this 9 and 14? See, it says subtract. The second sign was minus. I'm waiting to fill in the plus and the minus. Can I subtract the outer and inner to get this term here? Yeah. So how do I need to arrange the plus and the minus? You know, since this is a negative, the 14x would need to be negative. The 9 positive. So making it work out, what sign goes in front of this 3? A plus or a minus? A plus. If I put a plus here and a minus there, the nice thing about factoring is you always know if you have the right answer. Not when you punch it in and it tells you right or wrong. But why do I say you know? Well, foil it out. Let's start foiling it out. The 2x times 3x, is that giving me 6x squared? So first, outer, that's this big red mark. 2x times negative 7 is a negative 14x. Inner, 3 times 3x is a positive 9x. And then 3 times negative 7 is a negative 21. Does 9x minus 14x give me a negative 5x? Yeah. Okay. It takes a bit of practice. If it's been a while since you factored, or if you took Math 371 during the summer, then you factored recently. Okay, it's going to be easier for you than someone that hasn't factored in a long time. So what does that mean? That just means you've got to work at it a little harder if you don't remember this. Okay? But this factoring stuff we're going to have following us throughout the semester. So I click right here. And it really doesn't matter which set of parentheses you write first. Okay? You could type in the 3x minus 7 and then the 2x plus 3. It doesn't matter. You just got to have one set of parentheses with a 2x plus 3 in it. And another set of parentheses with 3x minus 7. When you type stuff in on Pearson, never, ever, ever hit a space key. Okay? Never, ever, ever use capital letters. It will space it correctly if you do this, if you punch it in right. Okay? I'll see. Check my answer. And you know what? Maybe this, do I need to make it a little bigger? Oh, too big. There. Okay. Any questions there? You can always foil this stuff out to get your, to check and see if you're doing it right. Let's go on to the next even number problem. Number 4. Ooh, okay. This one has bigger numbers. Let me write it down. 56 s squared. I learned years ago that s's give trouble. S's always wind up looking like 5s. So we have 56s squared plus 121s, that's an s, it looks like a 5, plus 63. So I'll write it down. And even though these numbers are larger here than the other one, there's actually something good about this problem. What's the second sign here? Yeah, the second sign is plus, so we just have 2 of the first sign, so we can fill those in immediately. We don't have to try to decide where does the plus go, where does the minus go. The first sign is plus, so there it is, plus plus. And now, let me think. Numbers that multiply together to give a 56. Well, I'm going to write out all of them that I can think of. 1 times 56. And what about 2? Is 2 times 28? Does that give you a 56? 2 times 28? 3 doesn't divide evenly into 56. But I think 4 does. What's 56 divided by 4? 14? 5 doesn't divide evenly into 56. 6 doesn't. What about 7? 7 times 8 is 56. There are the numbers that multiply together to give 56. One pair of these numbers are going to be the thing that goes in the first spot. 1x, 56x, or 2x, 28x, or 4x, 14x, or 7x and 8x. Now for 63, what numbers multiply together to give 63? Well, I know 1 and 63. 2 doesn't divide into 63. What about 3? 3 times what would give me 6? 21? 4, 5, 6 doesn't. 7 times what would give me 63? 9? 7 times 9. Well, how do I want to start this? I'm going to go ahead and start with the 2 numbers that are closest together. And I'm going to try to pair the 7 and 8 with the 7 and 9. Let's see if we can get it to work out. By work out, I mean, can we get those middle terms, the outer and inner terms, to add together to give 121? So if I put a 7x and 8x there, if I'm going to try it with the 7 and 9, could I put the 7 right here? No. If it's going to work out, it would have to be this way, a 9 there and a 7 there. And then FOIL it out to see, are we getting 56s squared? Oh, shoot, look at what I did. I wrote an x here and here. Should be an s, and you might think, well, that's no big deal, and it really isn't theoretically. But if I typed that in onto my math lab, it's going to give me a wrong answer with no hint as to what did I do wrong. Okay? I'm going to make my little outer. and enter marks to see if these things will add together to give 121s. You see the outer 7s times 7, that's a 49s. And what about the inner? The 9 times 8s? 72s? Oh gosh, it's not going to add together to give 121. If it is, we're finished. If it isn't, silently I'm going to stomp my foot and curse and move on and try a different pair of numbers. 72 plus 49, I think that's it. Okay? So 7s plus 9 times 8s plus 7 is what I'm going to type in. And that's an S. You know what? Oh gosh, now I've made it look like 75 plus 9. 8s. Trying to write it neater there. I'm not so sure I succeeded. It's not 75 plus 9 or 85 plus 7. It's 7s plus 9. Oh, let me come over here. Okay, you can see that. Oh, you know what? I think I did make it too big. Oops. There. Let's see. Parentheses. What was it? 7s plus 9 and 8s plus 7. By the way, you could have typed the 8s plus 7 first, and then the 7s plus 9. The order in which you write the two parentheses doesn't matter. So I will click check my answer. Any questions? Let's just try that one. Oh, number 5 is kind of tricky. I'm glad I clicked on that one. In order to get this stuff foiled out, there's got to be a certain pattern to these things. If you look at number 4, the s squared, then the s, and then a number that has no variable. It should have a variable squared, variable, no variable. That's the order it should be in order to factor it. On problem 5, is it in the correct order that we need it to be in? No. Okay. So, let me write it down. All right. 9s squared minus 5 minus 44s. First thing we need to do is write it in the standard form. There should be a variable squared. We have that. Then we should have just the variable, and the last thing should be the constant. So the way I'm going to factor it is like this. 9s squared. I'm going to write the minus 44s next, and then the minus 5. And Then I'll write out numbers that multiply together to give a 9, and then write out numbers that multiply together to give a 5. 1 times 9, 3 times 3, the 5, 1 times 5. Oh, that's it. 1 times 5, isn't it? Okay. I'm going to draw my 2 sets of parentheses, and then I got to decide, okay, should there be 2 pluses in the parentheses, 2 minuses, or 1 of each? How do I decide that? You look at the second sign. That second sign is a minus. That means we need a -5 when we multiply. The only way you'll get a negative is if there's 1 plus and 1 minus. On my table, it's that second line. If the second sign is negative, you have 1 plus and 1 minus. Wait to fill them in. Okay? But what did I do? I just made a little note to myself that there should be a plus and a minus. Normally, I put in the first numbers here and here, but on this one, or I put those in first, since there's the only possibility for 5 is 1 and 5, let's fill that in. 1 and 5. Usually, I would try the 3 and 3, unless that middle number is just considerably larger than the other numbers. I think if I put a 3 and 3 here, I'm not going to get a 44s. My thoughts are to try the 1 and 9 on this one. So, if I'm going to try the 1 and the 9, how should I arrange them? If I put, you know what, I'm going to do this. If I put 1s and 9s here, am I going to get 2 numbers that could subtract to give me a 44? No. So, this is what my brother was trying to stop me from doing yesterday. If I'd used pencil, I could erase it, but no. Again, my goal is to show my thought process. So 1 and 5. I'm still thinking the 1 and the 9 are going to work, but I'm going to reverse it. What if I put the 9s and with the 1 and the s with the 5? 9s times s. Can y'all sort of do that now, the outer and inner in your head? Are we going to get 2 numbers that we can subtract to get this middle term? See, right here we have is that a 45? 9 times 5 is 45, an s. And what's the other one? 1s? So the 1 and the 45, we can sure subtract them to get a -44s. How are we going to get that -44s? The 45 should have a plus or a minus in front of it. Which one? Minus, a plus here. So what goes in front of this 1? In front of the 1, am I going to put a plus or a minus? Plus. And right here, a minus. One way to see if it's right is you can type it in, but you can also FOIL it out. FOIL it out and see, are we getting 9s squared minus 44s minus 5? As we sure are. This is a trial and error process. There's another method called the AC method for factoring, which I'll never do in class. but I'm going to mention it briefly just in case you're thinking, wow, I seem to recall. Do you ever recall where you have to multiply the first number and the last number, and then get two numbers that multiply to give that, and add together to give this, and then rewrite with four terms and grouping? You know, by the time you do that method here, the AC method, the first thing you would do is multiply 56 times 63. I assure you it's not going to turn out easier than just a trial and error process the way I'm doing it. Okay? And you might disagree with me, but I've done this for 30-something years for a living. After doing it for 30-something years for a living, I can tell you it's going to work out easier that way. And if you doubt it, try it, and you know that AC method, try it on this. You multiply this number times this number, and then you find two numbers that multiply together to give those numbers that add up to give this. And it's yes. Plus, you got to know how to do factor by grouping, which otherwise you don't need to know how to do that. Okay? So, have I punched this in so that y'all can feel confident that I'm getting it right? I'm not telling y'all the wrong stuff. S minus 5. Notice I'm putting the S minus 5 first for no reason, just to show you that there's no order. It doesn't matter if you punch in the first set of parentheses or the second set first. S minus 5 times 9S plus 1. Check my answer. Any questions? Okay, number 6. By the way, these problems are all the same. It's just different numbers. 15. Oh, good. There's an x in this one. 15x squared. I say good because that's what I'm going to want to write. And it'll wind up being messy like that other one. Plus 11. Well, this one's already in the standard form that we need it in. X squared, x constant. So unlike number 5, we don't need to rewrite it. X squared, x constant. I'm just going to go ahead and draw my two sets of parentheses. And let's decide on the signs that go in here. Are we going to have plus, plus, minus, minus, or one of each? How do we decide? Well, the second sign is a plus. So what was that rule about the second sign? The second sign is plus. You have 2 of the first one. Okay? The second sign is plus, 2 of the first one. So you can fill it in immediately. The second sign is plus, minus, and minus. 2 of the first. The second sign is plus. You have 2 of the first sign. Now I'll write out the numbers that multiply together to give 15. Well, there's not a lot of them. 1 times 15, 3 times 5. And write out the numbers that multiply together to give 11. Again, not a lot of them. Just 1 times 11. And if you're sitting there thinking, oh my gosh, that idiot. Well, of course there's more numbers than 1 times 11 that give 15. 2 times 5.5. 4 times 2.75. No. I just mean counting numbers, okay? I don't mean all the real numbers. When I say write out the numbers that multiply together to give 15, I just mean the counting numbers. I don't want you to be sitting there thinking, wow, goodness, that idiot, 30 times a half gives 15. No. Not real numbers, just counting numbers. There's only one possibility for 11. I think I'm going to try that first. I'm going to put a 1, or I'm going to go ahead and put that in, because there's no other possibility. 1 times 11. Then, which pair do we want to try first? The 3 and 5? I'll try the 3 and 5. So I'm going to put 3x and 5x. And let's see. We've been pretty lucky so far. By that I mean we get it pretty quickly. But what about this one? Is that going to give me a negative 14x when I do outer and inner? No, I'd have what, a negative 33 and a negative 5. That's not going to add together to give a negative 14. So what will I do? I'll say, nope, that don't work. And what I'm going to do is, let's try reversing the 3 and the 5. If I put the 5x here, and the 3x there, is that going to give me a negative 14x in the middle? What are y'all thinking? I'm thinking it isn't, is it? What's the outer? If you're foiling it out, the outer would be a, yeah. And then the inner, yeah. Are those going to add together to give a negative 14? No. So another x. Well, okay, so I'm thinking the 3 and 5 definitely don't work. So I'm going to do the same thing now with the 1 and 15. I'm going to leave the 1 and 11 where they are. And I'll try 1x times 15x. So I'm beginning to think that we might have encountered one that can't be factored. If y'all do the little marks in the outer and inner, is that going to give me a negative 14x? No. Yeah, I mean, yes, you're right. It's not. Okay. You'd have a negative 11x and a negative 15x. Those don't add together to give a negative 14x. Yesterday, when I was doing this problem, I'll give you a hint. Everyone's number 6, the answer is prime. So you should do this assignment today so you can remember that, okay? If you wait a week or two, a month or two to do it, you'll probably not remember that problem number 6 on the factoring assignment is prime. And put them, this one definitely. Do we even need to try it? I mean, do y'all need to punch into your calculator 15 times 11? Or can y'all decide, yeah, this is not going to give us a negative 14x? Okay. Oh, wait. Oops. See there? Whatever, 15. Okay. 15 times 11. 15 times 10 is 150. 15 times 1. Is that 165? Yeah. So there. I feel better now that I've shown that these two obviously are not going to add together to give negative 14x. So, depending on how they word it, there's 2 ways I've seen them saying it on there. It'll either give you the option that the polynomial is prime, or what I prefer for it to do is actually write out not factorable. I think on number 6 it gives you prime as the option. Yeah. But Like on number 5, I think the option that it said was not factorable. They mean the same thing. Okay? It's number 6. And again, everyone's number 6 is going to be not prime. Okay? Not factorable. Let's do the next even number question if there aren't any, the even number problem if there aren't any questions. Are there any questions? Any questions over in the peanut gallery over there? No questions? Okay. Number 8. And half of these people are thinking, I'm moving over there the next time, okay? But, okay. I was thinking Tim, the other Mr. Precella, would be here by now, but no, okay. I can do it. 5w squared minus 14w minus 3. By the way, number 6 is the only one that's prime. So that when you're working these, you don't have to start thinking on every one of them. Prime. Let me see. This one's already in the form it needs to be written in. W squared, W, constant. Do I need to show the table, or do y'all have an idea of what the signs are going to be? Plus, plus, minus, minus, or one of each? Okay, the second sign is minus. So 1 plus and 1 minus. If the second sign is minus, you have 1 plus and 1 minus. You wait to fill them in. The outer and inner, you're going to be subtracting those numbers in order to get the middle. Oh, well, heck. There's not a lot of possibilities for the pairs of numbers here, are there? 1 and 5 and 1 and 3? So I'll say 1w times 5w. Can y'all see this in your head? In order to get that middle term, where should I put the 3? Should it go here? Yes? Okay, let's try it. I'll put the 3 there and the 1 there. When I do the outer and inner stuff, I have a 1w and a 15w. I want a negative 14w. Well, I can subtract 15 and 1 to get a 14. So help me with the signs. The 15 would need to be negative. The 1 positive. So in front of the 3, I put a, and in front of the 1, I put a plus. Okay. W minus 3 times 5w plus 1. Any questions there? So let me see. Parentheses, w minus 3, parentheses, open parentheses, 5w plus 1, close parentheses. Okay. I'm going to give a little terminology that we'll be seeing off and on throughout the remainder of the course. I'm going to define what we mean by the word quadratic. A quadratic, is that purple showing up or should I be using black? Equation. I'm not defining what an equation is. I'll just tell you what an equation is. It's a statement with the equals. Okay? A quadratic equation can be written in the form ax squared plus bx plus c equals 0. In the first algebra class you would have ever taken, the first thing that's done in Math 371, the developmental math, they combine like terms, and then the very next topic is something called solving linear equations. A linear equation has no exponent. Okay, it just has an x. 3x plus 5 equals 0. A quadratic equation must have an x squared. So another way I could have said this, a quadratic equation must have an x squared term. Maybe that would have been a better way of saying it. But if I wanted to state a formal definition, and that's what I wanted to do right here, just so y'all can see some formal definitions written, there's something else I need to write here, and I'm running out of room. A, B, and C are just numbers, any number you want, except for what? If we're going to have an x squared term, A can't be what number? What's the one number A couldn't be? Because if it were, we wouldn't have an x squared. 0. So here's my formal definition of a quadratic equation. A quadratic equation can be written in the form ax squared plus bx plus c equals 0. A can't be 0. In other words, a quadratic equation must have an x squared term. And one way to solve quadratic equations is by factoring. How to solve this is a QE standing for quadratic equation. Step 1 is usually done for you, but not always. Write the equation in standard form. In step 2, factor the equation. That's where you're going to write it with the 2 parentheses. And then step 3, set each factor equal to 0 and isolate the variable by performing the opposite operation to both sides of the equal sign. Comma, beginning with addition and subtraction. Those long sentences I write that sometimes tickle people. Years ago, I was at a restaurant and a waiter was, oh, y'all teach math at Delmar? Yeah, we teach math. And then he went on to say, oh, he's taking math right now with Mr. blah, blah, blah. I won't say the name. And I was, oh, wow, how's it going? Just trying to make polite conversation, saying what I think I need to say. He began, well, it's going okay, except that man is an idiot. I immediately decided it's now time to disengage from this conversation and sort of, I'm sorry to hear that. He said, yes, you won't believe what he tells us to do. He tells us that we need to study the instructions and stuff. Look at this problem, number 8. All the problems we've done so far, the instructions say factor completely. When it says factor completely, you write 2 sets of parentheses as your answer. Starting with number 10, it's not going to say factor completely. But anyway, I was like, oh wait, that's a very good idea. Your teacher's not an idiot. It's a good thing that he's telling you to pay attention to those instructions and stuff. And at that point, the waiter decided, I'm going to disengage from this weirdo. He's here telling me to study the instructions also. So he hightailed it, and we didn't see him again. I don't think I got a refill or anything on my drink. But anyway, and that's one of those things. I live in the past, I know. I always think about that, because here it might look similar to what we were just doing, but look at the instructions. Solve the equation for W. It doesn't say factor completely. Also, notice how this problem looks different. When the problem is stated up here, is there an equal sign? There might be an equal sign down here where you're putting the answer, but not in the original statement of the problem. When you're solving an equation, your answer is going to be 2 numbers. Simplify it, use a comma to separate answers as needed. Notice, on number 8, at any time, the ones we've been doing, has it talked about using a comma to separate your answers? Well, no. I'm mentioning this because I remember one semester, quiz 1 had a lot of problems like this. Just factor completely. And the students in the class, they did really well on the test 1, but they did poorly on the quiz 1, which was the easier thing. And I had to look back and figure out what the heck happened. Well, the students, instead of stopping right here, what do you think they were doing? They were going through solving. So that student that said his teacher was an idiot for telling him to study the instructions, no, that is a key to success in a math class. Okay? On this one, our answer is not going to be 2 sets of parentheses. It's going to be 2 numbers. So let me write this one down, and then we'll follow those 3 steps that I wrote out for us. Problem number 10. 2w squared plus 17w plus 36 equals 0. And you're saying, well, you say the instructions are so important, but you didn't write any of them down. Yeah, I didn't. I don't write down the instructions here. But you still read them on the computer screen, okay? So the first step is to write it in standard form. Well, standard form has x squared, x, well, we have w, constant equals 0. This one's already in standard form. So we move straight on to the factoring. Let me see. I'll think to myself, okay, numbers that multiply together to give 2. Well, 1 times 2. Numbers that multiply together to give 36. 1 times 36. 2 and 18. Does 2 times 18 give us 36? 3 times what is 36? Is that 12? 4 divides evenly into 36, doesn't it? Is 4 times 9 36? And last pair of numbers, 6 times what? 6. Well, I'm going to draw my 2 sets of parentheses. And decide on the sign. Have y'all mastered that second rule? The second symbol rule. The second sign here is a plus, so Both of them are plus. 2 are the first. So I'll put plus and plus. Now, I'm definitely going to just fill in the 1W and 2W first because there's nothing else, okay? That's the only possibility. So we just got to play around with it until we make it work out using these numbers here. I claim we don't even need to bother trying the 6 times 6. Why? Could we have a 6 in this set of parentheses? No, you can't have two numbers with a common factor other than 1. Okay? In particular, you can't have 2 even numbers. So the 6 and 6 can't possibly work. Well, let's try the 4 and 9. Okay? Or if there's another pair, like the 2 and 18 definitely can't work. Why am I saying 2 and 18 can't work? I couldn't put the 2 here and I couldn't put the 18 here. Right there. So, I'm going to try the 4 and 9. If you want to try the 3 and 12, okay. But I'm going to try the 4 and 9 because that's just how I normally do it. I start with the numbers closest together on the number line and then move on up. The 4 and 9, but I can't put the 4 with the 2. So let's try here. 4 and 9. Can y'all do the outer and inner there and see if we're getting a 17W? We are, aren't we? We have an 8W and a 9W. That's giving me a 17W. I claim we have it factored correctly now. Are there any questions on that? So what we've done is we've started off with a quadratic equation. We've now factored it so there's no exponent in either set of parentheses. These are called linear equations. Set each factor equal to 0 and isolate the W. I'm going to set the W plus 4 equal to 0. And then I'm going to set the 2W plus 9 equal to 0. We're going to now, not actually written out, how do you solve a linear equation? Isolate the variable by performing the opposite operation to both sides of the equal sign, beginning with addition and subtraction. So I'm going to solve this one here. I'm going to get the W by itself. So I just have W equals a number, and that'll be my first answer. The opposite of adding 4 is subtracting 4. So I'm going to subtract 4 from both sides. And does that isolate the variable? I'd have W equals negative 4. Yesterday when I was doing this, my brother said, circle that negative 4. There's my first answer. Negative 4. Now, somewhere along the way, usually it's like very early on in the first algebra class, you do this isolating the variable stuff, solving linear equations. Like here, to isolate this W. This is 2 times W. The opposite of that would be division. The opposite of adding 9 is subtracting 9. Well, what are we going to do first? Divide or subtract? Beginning with the addition and subtraction. So subtract 9 from both sides. So we have 2W equals negative 9. I know it's getting low down there. It's hard to see. And now what do I do to get the W by itself? I've got to get rid of this 2 by dividing both sides by 2. So we have a fraction, negative 9 over 2 is our second answer. Okay? Negative 4 and negative 9 over 2. How do you tell the difference between this and problem number 8? The ones where you're just factoring. Well, it is, the instructions for number 8 say factor. The instructions for number 10 say solve. When it just says factor, your answers are 2 sets of parentheses. When it says solve an equation, your answers are going to be numbers. We use a comma to separate the numbers. It doesn't matter which number you type in first, the negative 4 or the negative 9 over 2. It's easier to get it right, not to have a typo, if you do negative 4, comma, negative 9 over 2. But I want to show something. If you had written negative 9 over 2, here's what sometimes students do. They'll then go, comma, negative 4. Do y'all think that it's going to count that right? No, that comma and negative 4 should not be in the bottom of the fraction. I'm going to get out of the fraction and put a comma, I'll go right arrow, then put the comma. The comma doesn't go in the bottom of the fraction. It goes between the two numbers, the negative 9 over 2 and the negative 4. Pearson doesn't really like mixed numbers. In algebra, it doesn't lend itself. So if you want to write this as 4.5, don't. Just leave it as 9 over 2, an improper fraction. Any questions on that? And it is sort of important to be able to spot how does this differ from what we were doing. Number 12. Write it down. We've gone right on through the break, but we only have this problem and one more that I wanted to do. So, if you need to step out, I've never said that there was anything wrong with you stepping out or something. If you need to take a break, you won't miss anything because it'll all be on YouTube in a little while. So, let's see. Problem 12. Something unusual about this one. What am I thinking is unusual about it? It's not in the right order. It's not in that standard form. How should I rewrite this? Or how do I need to write it? The c squared term should be first. So rewrite it as c squared. Then, am I going to write the plus 13c or the plus 40 next? Yeah, c squared c plus 40. It's sort of late in the game to get a pretty easy factoring problem. This one is called a simple trinomial because there's not a number in front of the c squared. I didn't want to just do easy examples, okay? The ones I've been doing I've picked out because those are the harder ones. But here, why am I thinking this will be easier to do? Well, because you just put C and C. You don't have to worry with putting a number in those first spots. In the last spots, you got to come up with numbers that multiply together to give 40. 1 times 40. 2 times 20. What else? 4 times 10, and I heard it. The last one, 5 and 8. When there's not a number in front, you can almost just sort of look at this and look at the pairs and figure out which pair is going to add together to give you that. I'm thinking the 5 and the 8. So not all of the factoring problems are that difficult, okay? If I draw my two sets of parentheses, for the second sign is plus, so 2 of the first. So we can put plus and plus, C and C. What pair of numbers did we say would work here? 5 and 8. Do I type in C plus 5 times C plus 8? No. This is solve an equation, so there should be numbers as your answer. C equals, use a comma to separate them. So let's see, let me go ahead. Can I set C plus 5 equal to 0? How do I isolate the C? I subtract 5. Here's something that I'm going to be doing as we go through the semester. Instead of saying minus 5, when I'm just moving and getting rid of a number and moving it over, I draw a little arrow like that red arrow. And all that means is move the 5 over and change its sign. And that's the same thing as minus 5. Okay? Like right here, C plus 8 equals 0. Sometimes students ask, do I have to show all those steps? And my answer is always the same thing. Your goal and my goal are different. Your goal is to get the answer as quickly as possible in as few steps as possible. Imagine if that were my goal up here. Imagine that. Oh, wow. My goal is to try to show my thought process. So subtract 8 from both sides. So negative 5 and negative 8. Negative 5 and negative 8. Come over here. Type in negative 5, comma, negative 8. Check my answer. Any questions? Last example for today. Number 15, 12w squared plus w equals, is that an equal 6 or equal 8? It's a 6, okay. 12w squared plus w equals 6. 12w squared plus w equals 6. This is the last problem, so it's got to be the hardest one. My brother always, it turns out he hates it when I say that. I didn't know that. And I'm usually joking about that. I mean, they're not really arranged in level of difficulty, but I'm just talking, what's different about this problem? It doesn't say equals 0. A quadratic equation has to have that standard form with the 0 on one side. Okay, like number 10, it had equals 0. Number 12. Here, what am I need a 0 there. What do y'all think I could do to get a 0 there? Subtract 6. Minus 6, minus 6. I'm just going to do that. My little universal symbol, meaning minus 6 from both sides. All it's going to do is move the 6 over and change the sign. Let's see. Now I'll start the factoring. Numbers that multiply together to give 12. 1 times 12. Remember once when I was teaching this, a student on a problem just like this said, stop right there. That's what I don't know what you're doing. How are you getting those numbers? And this was, the number was a 12 there. The rest of the students laughed. I immediately, began a gentle encouragement for the person to get the multiplication tables and start refreshing your memory from the multiplication tables. Now, if this had been 312, yeah, you're going to have to use a calculator to try to figure out just numbers that multiply. But for 12, that's straight from the multiplication tables. Just like 6. 1 times 6 and 2 times 3. I'll draw my 2 sets of parentheses. And when I draw the parentheses, it's when I decide about the signs. The second sign is minus, so what are we going to have here? Are we going to have negative, negative, plus, plus, or one of each? One of each. If the second sign is minus, one of each sign, so I'm going to weight the figure to fill them in. And it's just sort of up to you now. Which pair of numbers do you think I'm going to try first? I think I'm going to try the 3 and 4. And I think I'll try it with the 2 and 3. But it is a trial and error process. 3W, 4W. If I'm trying it with the 2 and 3, the 2 can't go with the 4. The 3 can't go with the 3. So it's going to have to work like this. 2 and a 3. Now let me look at this outer and inner stuff. Ooh, can y'all see? Oh, okay, good. I was afraid it was down too low. The outer is a 9W. The inner is an 8W. Is this going to work out? Can we subtract those to get this middle term, a 1W? I think we can, right? Y'all following what I'm doing? Any questions? So the 9, is that what would need to be positive and what would need to be negative in order to get a 1W? I would make the 9 positive, the 8 negative. So in front of the 2, what am I going to write? Plus or minus? Is that a minus and a plus in front of the 3? Look at that factorization. Any questions there? Now, set each factor to 0. So we have 3W minus 2 equals 0, and 4W plus 3 equals 0. If it had said factor completely, we'd type in the 2 sets of parentheses and stop. But it isn't. It says solve the equation. So isolate the W by performing the opposite operations, beginning with addition and subtraction. So the first thing I would do is add the 2 to both sides, so that just moves the 2 and changes it to a positive 2. And then what? What will I do next? Divide by 3. So 2 over 3. There's one answer. Over here. Are y'all caught up? I subtract the 3. And then divide by 4. Negative 3 over 4. And 2 over 3. Be careful typing those in. here. Okay. You could just use a slash bar. If it's just a fraction in the form one number over a number, you don't have to use the little hot button if you don't want. You just go 2/3, and that converts it to a fraction. Don't put the comma down there. Hit right arrow or else click to get out of the fraction. Then put the comma. And then -3/4. Okay? Notice how the comma is not down there in the bottom of the fraction. There's some of the problems here, it'll count it right if you put the comma in the bottom of the fraction. But once you get out of this assignment and go further on, it will not count it right if you put the comma down in the bottom of the fraction. It should be between the two fractions. Okay? And now you can go and talk to someone. Oh, my teacher is such an idiot. He talks about where to put the comma between the two fractions. Okay? But I'd hate to see you get it counted wrong because you put the comma in the wrong place on a test. Okay? And if you did just if you had it wrong solely because the comma was in the wrong place, I'll look through those, and I'm usually pretty good at catching that. Okay? So, are there any questions here? This has been a fast week, hasn't it? I don't think I'll see y'all again till Monday. Am I right? Yeah. So we're moving on along here. Huh?
Are we having you or your brother?
Oh, well, I was thinking he'd be back. I guess his appointment, maybe he had to wait longer than it should be, but normally it'll be both of us. Okay? This is the little peanut gallery. I just got to say this so you know, y'all don't have to sit over here. You can always come over here if you want, okay? And the same thing goes for y'all. If y'all are like, I want to go away from here, y'all can sit over here, okay? I'll open the wall more if y'all want it open, okay? But I sort of stopped today at that point as I was doing it all, okay? So if there's any questions, I'll be glad to try to answer them. But it just dawned on me, I better stop this recording right now. And it